Hello everyone, we are Team CARBONX and we are excited to introduce our innovative project, Carbon Sherlock, the AI detective that unmasks carbon credit fraud and empowers climate action. So here comes our problem statement. We address a massive global issue, carbon credit fraud. The global carbon market is worth over $100 billion and it's growing at 50% every year. But here is a problem, causing $40 billion plus annual loss and destroying trust in climate action. This leads to widespread fraud. So here are some real fraud cases which include Brazilian forest scam, $100 million worth of forest protection, credit sold over 80% of the land was already protected by the law. Ghost tree projects. Credits issued for trees that were never planted or died within months. Double counting. A wind farm selling the same credits in multiple countries, 3 to 5x more credits than actual carbon reduction. Companies believe they are carbon neutral, but in reality, they may not be. We can't afford fake climate solutions anymore. So here comes our solution, Carbon Sherlock, an AI powered system that uses satellite imagery and IoT sensors to monitor carbon offset projects in real time. It automatically detects fraud using computer vision and pattern recognition algorithms. All verification data is stored on an immutable blockchain ledger, preventing tampering and double counting. The system delivers instant alerts on underperformance, cutting verification delays and cost while ensuring only genuine carbon projects getting funded. So let's get into the working of it. Firstly, satellite capture daily images of forest and renewable projects. And then our AI analyzes them to detect illegal deforestation or fake growth, followed by the IoT sensors measuring carbon levels on the ground, confirming data. All these verified records are stored on blockchain, impossible to alter or fake. Together, these layers create a transparent, tamper proof system that exposes fraud instantly.
Here is the Carbon Sherlock dashboard, the centralized user interface that brings together all our advanced monitoring components in one place. First, the dashboard displays the machine learning fraud detection results. This section shows whether a given carbon credit project is labeled as legitimate or suspected fraud based on our isolation forest model. You can see detailed risk scores derived from critical project features, helping stakeholders quickly identify suspicious projects. Next, we have the satellite image monitoring panel powered by NDVI analysis. This visualizes changes in vegetation health over time by comparing satellite images captured before and after the project. It automatically flags forest loss or improvement, providing real world validation of environmental claims. The dashboard also streams real time IoT sensor data collected from on site sensors, measuring temperature, humidity, air quality, and atmospheric pressure. This live environmental data helps verify conditions reported by projects and detect anomalies that might indicate fraud or tampering. Finally, the dashboard integrates blockchain verification. Every carbon credit record and analysis result in cryptographically stored on the Ethereum network via smart contracts. The dashboard shows transaction hashes and confirms data immutability, ensuring traceability and resistance to fraud. In summary, the Carbon Sherlock dashboard is a powerful, user friendly tool combining AI, satellite imagery, IoT, and blockchain to offer transparent, accurate carbon credit monitoring and fraud detection. Now, let me introduce you to the hardware prototype of Carbon Sherlock, the physical sensor system that gathers real time environmental data to support fraud detection. At the heart of our hardware setup is the ESP32 microcontroller, a compact and Wi Fi enabled board that acts as the central brain. Connected to it are multiple sensors. First, the DHT22 sensor measures temperature and humidity, important for understanding local environmental conditions. The MQ135 sensor detects air quality, helping us track pollution levels that affect carbon sequestration. The BME180 sensor measures atmospheric pressure, temperature, and humidity with high accuracy for robust monitoring. These sensors are precisely wired to the ESP32 using a breadboard for easy prototyping, with power and data lines carefully connected as per specifications. Our Arduino code reads sensor values periodically, packages the data into JSON format, and sends it wirelessly via Wi-Fi to the Carbon Shell Log Flask backend endpoint/IoT data. This real-time data stream allows us to monitor environmental parameters on site, enriching our fraud detection system with physical measurements. Overall, this hardware prototype integrates cutting-edge IoT components to ensure trustworthy, continuous environmental monitoring, making Carbon Sherlock a powerful tool for validating carbon credit projects.
So now let us discuss technologies used in our project. Our tech stack is designed to ensure a secure, fast, and decentralized verification ecosystem. The front end is built using React.js and Material UI, and backend is powered by Fast API integrated with PostgreSQL and MongoDB. For machine learning, we use TensorFlow, PyTorch, Random Forest, and LSMT. Finally, our cloud infrastructure, powered by AWS and GCP, ensures scalability and reliability across all operations. So, benefits of our project are corporates and industries achieve verified carbon neutrality with authentic carbon credits. Governments strengthen climate compliance and enforce sustainability policies. So, market opportunities of our project are $1 trillion market by 2030. So, firstly, $1 trillion market. So, market opportunities in our project. We believe that $1 trillion market by 2030. Firstly, $1 trillion market size by 2030. Secondly, 50% of annual growth rate in our project. Now, 5,000 of companies with net zero goals, 130 countries with climate commitments. Talking about our business model, it takes 70% of the transaction fees, 2 to 5% of carbon credit value, and 2 to $5 billion potential at scale. Secondly, it provides SaaS platform, nearly 25% of the cost. Second, data analytics, up to 5%. 4. Unit economics, 97% of the gross margin, 12 to 1 LTV SaaS ratio. At the end, the conclusion of our project is high resolution satellite analytics precision, IoT sensing, immutable blockchain, and advanced AI fraud detection. It eliminates ambiguity, exaggeration, and manipulation in carbon credit verification, restores credibility in a sector where trust has long been compromised.